Azlan Adnan, M.A., presents The History of Rice, the Grain That Built Half the World. Tuesday, the 18th of August, 2026. From wild grass to civilization's staple grain. Half the people alive on Earth today eat rice as a staple. Not bread, not maize, not potatoes, but rice. The grain provides roughly 1/5 of humanity's dietary energy and has done so in one form or another for thousands of years. Wars have been fought over rice. Empires have risen because of it. Governments have taxed it, armies have depended upon it, merchants have carried it across oceans, and entire societies have organized their calendars, rituals, and working lives around its planting and harvest. Few plants have had a greater influence on human civilization. When the first farmers began cultivating wild rice in the wetlands of eastern China nearly 10,000 years ago, they could not have imagined that their modest experiments would eventually produce the staple food of billions of people. Yet the history of rice is ultimately the history of a remarkable partnership between a plant and the human species. We changed rice, and rice changed us. The first rice farmers. The story begins in the lower Yangtze River Valley, in what is now eastern China, roughly 9,000 to 10,000 years ago. The region was a landscape of rivers, lakes, marshes, and seasonally flooded wetlands. Growing among the reeds and other aquatic vegetation was the wild ancestor of Asian rice, Oryza rufipogon. Wild rice was not an obvious agricultural miracle. Its grains were relatively small, and when they ripened, they tended to fall from the plant, allowing the seeds to disperse naturally. For a hunter-gatherer, however, those seeds represented something valuable, a concentrated source of carbohydrate that could be collected, dried, and stored. The archaeological evidence suggests that the transition from gathering wild rice to cultivating domesticated rice was gradual. At sites such as Shangshan in Zhejiang province, archaeologists have found evidence of rice exploitation dating to around 10,000 years ago, including rice remains associated with early sedentary communities. At first, people probably gathered wild rice wherever it grew naturally. Gradually, however, they began influencing where and how it grew. Seeds from particularly productive plants could be deliberately scattered near settlements. Plants that produced larger grains were more likely to be harvested and replanted. The process was unconscious plant breeding on a generational scale. Domestication was therefore not a single invention. There was no ancient farmer who suddenly looked at a wild rice plant and decided to invent agriculture. Instead, thousands of small decisions accumulated across centuries. Keep the plants with the largest grains. Save the seeds that do not fall before harvest. Grow them in wet ground close to the settlement. Repeat the process next year. Repeat it again for the children. And then for their children. Eventually, the plant itself changed. The grains became larger. The husks became easier to remove. The plants became better adapted to cultivation. Most importantly, the characteristic known as non-shattering became dominant. Wild rice naturally releases its mature seeds. Domesticated rice tends to retain them on the stalk until humans harvest the plant. That apparently minor genetic change was revolutionary. It transformed rice from a wild plant that reproduced itself into a crop designed, in effect, to reproduce through human labor. Rice and the birth of permanent communities. Rice cultivation changed more than the contents of people's stomachs. It changed their relationship with time and place. Hunter-gatherers could exploit seasonal resources by moving between landscapes. Farming encouraged people to remain close to their fields, storage facilities, and water sources. Settlements became permanent or semi-permanent, houses became more substantial, and communities began accumulating possessions and food reserves. Rice was particularly suited to this transformation because it could be stored. A successful harvest created a reserve against the future. That altered the economics of survival. A community that consumed everything it produced remained vulnerable to the next drought, flood, or crop failure. A community capable of producing and storing a surplus acquired something far more important than a meal: security. Surplus also created inequality and hierarchy. Someone had to organize irrigation. Someone had to allocate land. Someone had to protect the harvest. Someone had to supervise communal labor and resolve disputes. Once grain could be stored and measured, it could also be redistributed, exchanged, and eventually taxed. Agriculture therefore created both abundance and administration. Rice was one of the crops that helped make the state possible. Water, labor, and the engineering of landscapes. Rice has an unusual relationship with water. It does not necessarily require permanently flooded fields, but many traditional systems use controlled inundation to suppress weeds, regulate soil conditions, and create an environment favorable to rice. This encouraged farmers to manipulate water on a large scale. Channels were dug. Embankments were constructed. Fields were leveled. Small ponds and reservoirs were created. Drainage systems were developed to control the movement of water. The paddy field was therefore not simply a piece of agricultural land. It was a human-engineered ecosystem. This was one reason rice cultivation could support exceptionally dense populations. A productive wet rice system could produce substantial quantities of food from relatively small areas, provided that water, labor, and nutrients were available. The social consequences were profound. Paddy agriculture demanded cooperation. One farmer's irrigation channel might be another farmer's water supply. One household's failure to maintain an embankment could flood an entire neighborhood. Rice societies consequently developed institutions capable of coordinating large numbers of people. The connection between water management and political authority became especially important in China. States increasingly acquired the ability to mobilize labor on a scale beyond that of individual villages, constructing irrigation works, canals, reservoirs, and transport systems. Rice did not single-handedly create the Chinese state, but it became deeply embedded in the fiscal and administrative machinery of successive dynasties. Grain, taxation, and imperial power. Once governments discovered that agricultural surplus could be measured and collected, rice became a political resource. Taxes could be paid in grain. Soldiers could be fed from granaries. Officials could be supplied from agricultural surpluses. Public works could be financed by extracting part of the harvest. The state granary became one of the great institutions of pre-modern Asia. During the Han Dynasty, more than 2,000 years ago, Chinese governments maintained substantial grain reserves. In prosperous years, grain could be purchased and stored. During shortages, reserves could be released to stabilize prices and prevent famine. This was more than charity. Food security was political stability. A government unable to feed its population could lose legitimacy. A government that allowed grain prices to soar could face riots and rebellion. The control of food was therefore closely connected with the survival of dynasties. The Grand Canal demonstrated the relationship on an extraordinary scale. Constructed and expanded over centuries, the canal system eventually connected the agricultural wealth of the Yangtze Basin with the political centers of northern China. Southern China became the empire's great rice-producing region, while the north remained the center of political and military power. The canal was consequently much more than a transportation project. It was an artery of imperial government. Rice moved north. Taxes moved towards the state. Armies and officials could be maintained. The empire remained politically integrated. The history of the Grand Canal is therefore also a history of how geography, agriculture, and state power became intertwined. The Great Asian Expansion. Rice did not remain confined to China. Over thousands of years, it spread across much of Asia through a combination of migration, trade, cultural exchange, and agricultural adaptation. The chronology was not uniform, and rice cultivation developed differently in different regions, but its eventual geographical expansion was extraordinary. Rice reached mainland Southeast Asia and became deeply established in areas now comprising Vietnam, Thailand, Myanmar, Cambodia, and Laos. The tropical monsoon climate offered conditions in which wet rice cultivation could flourish. The great river deltas became especially important. The Mekong, Irrawaddy, Chao Phraya, and Red River systems created enormous agricultural landscapes in which rice could be cultivated on a large scale. Seasonal monsoon rainfall supplied water, while rivers replenished soils with sediment. Farmers developed sophisticated systems for managing these environments. In favorable conditions, multiple harvests became possible within a year. Rice consequently became the foundation of some of the world's most densely populated agricultural societies. Rice crosses the Himalayas and enters South Asia. Rice also moved westwards into South Asia, where its history became intertwined with another ancient agricultural tradition. The Indian subcontinent eventually developed numerous distinctive rice-growing regions, from the humid eastern Gangetic plains to the river deltas and coastal zones of southern India. Local varieties were selected for different soils, climates, water regimes, cooking properties, and cultural uses. Rice became deeply embedded in Indian civilization. It appeared in religious offerings, festivals, and marriage ceremonies. It became a symbol of fertility, prosperity, and abundance. In many parts of the subcontinent, scattering rice or grains of rice became a ritual expression of blessing. India also became one of the world's great centers of rice diversity. Thousands of traditional varieties developed through generations of farmer selection. Some were adapted to drought, others to deep water, salinity, poor soils, short growing seasons, or particular culinary requirements. This diversity would later prove invaluable to modern plant breeders. Japan and the transformation of society. Rice reached the Japanese archipelago considerably later than its earliest centers of domestication. Wet rice agriculture became established during the Yayoi period, beginning roughly in the first millennium BCE, probably through population movements and cultural transmission from the Korean peninsula and mainland East Asia. Its arrival transformed Japanese society. Agriculture encouraged permanent settlement and created new forms of social hierarchy. Control over productive paddy land became a source of wealth and power. Communities had to cooperate to manage irrigation, planting, and harvesting. Rice eventually became so fundamental to Japanese culture that the Japanese word gohan can mean both cooked rice and a meal. Rice also became a unit of political economy. The koku, conventionally defined as approximately the amount of rice required to feed one adult for a year, became a measure of agricultural productivity and political power. Samurai domains were assessed according to their rice income, and a lord's status could be expressed in terms of the number of koku his territory produced. In this sense, rice was not merely food, it was wealth rendered measurable. Rice and the sacred. The importance of rice extended beyond economics. Across Asia, rice became associated with life, fertility, prosperity, and divine abundance. Rice offerings appeared in temples and shrines. Rice wine became part of religious ceremonies. Harvest festivals marked the completion of the agricultural cycle. In Japan, the emperor's relationship with rice retained ceremonial importance, while in Southeast Asia rice became intertwined with local cosmologies. In Bali, the rice goddess Dewi Sri came to embody fertility and agricultural abundance. In many traditional societies, rice was treated as something possessing a spirit or life force that demanded respect. These beliefs reflected a practical truth. The harvest determined whether families ate. The harvest determined whether communities survived. The harvest determined whether rulers retained authority. It was hardly surprising that people came to regard the plant as sacred. Terraces, turning mountains into rice fields. Perhaps nowhere is the human transformation of the rice landscape more spectacular than in the mountain regions of Asia. The famous rice terraces of the Philippine Cordilleras turned steep mountainsides into enormous staircases of cultivated land. Their history extends back many centuries, although claims that every terrace visible today is several thousand years old are difficult to substantiate. The same principle appears across Asia. In China's Yunnan province, terraces climb mountainsides. In northern Vietnam, dramatic rice fields follow the contours of highland valleys. In Bali, interconnected terraces are managed through complex irrigation institutions known as subak. These landscapes required extraordinary collective labor. A terrace is useless without water. Water must enter at the correct point, flow through one field and then another, and eventually return to a river or drainage system. Rice therefore created not only fields but institutions. The subak system in Bali is particularly revealing. Irrigation, farming calendars, religious ceremonies, and community organization became closely connected, demonstrating how agricultural technology can evolve into a social and cultural system. Rice and the monsoon world. Rice also helped create one of history's great commercial networks, the monsoon trading system of the Indian Ocean and Southeast Asia. The seasonal reversal of monsoon winds made predictable long-distance voyages possible. Ships carried spices, textiles, ceramics, metals, and foodstuffs between India, Southeast Asia, Arabia, East Africa, and China. Rice traveled with these networks. So did farmers, technologies, cooking traditions, and religious ideas. The history of rice is therefore inseparable from the history of migration. People carried seeds with them, but they also carried knowledge, how to cultivate them, when to plant them, how to build terraces, how to irrigate fields, and how to cook the harvest. Rice was one of the great biological travelers of human history. The other rice, African domestication. The history of rice is often told as though all cultivated rice descended from the Asian species. That is not true. West Africa independently domesticated its own rice, Oryza glaberrima, probably around 3,000 years ago in the inland delta of the Niger River. African rice is generally lower yielding than modern Asian varieties, but it possesses valuable characteristics, including resistance to certain pests, tolerance of difficult environments, and adaptation to local African conditions. Its domestication represents an important example of convergent human agriculture. Different societies, separated by thousands of kilometers, independently looked at wild grasses and transformed them into food crops. African rice would later contribute genetic material to modern breeding programs, illustrating a recurring theme in agricultural history. Varieties dismissed as primitive or unproductive can contain genetic traits essential to the future. Rice becomes a colonial commodity. The arrival of European colonial powers transformed the geography of rice production. Portuguese, Dutch, French, and British merchants incorporated Asian rice into expanding systems of global commerce. Rice was increasingly produced not only for local consumption but for distant markets. In colonial Southeast Asia, commercial agriculture expanded rapidly. Burma, later known as Myanmar, became one of the world's great rice exporters under British rule. The transformation was economically impressive but socially disruptive. Land was increasingly drawn into cash-oriented agricultural systems, while farmers became vulnerable to debt, price fluctuations, and international markets. The logic of colonial agriculture was often brutally simple: produce what could be sold at the highest value to the imperial economy. Rice was no longer merely a crop feeding communities. It was an export commodity feeding global trade. Rice and the Atlantic slave economy. The story becomes darker in the American colonies. Rice cultivation developed particularly successfully in the tidal lowlands of South Carolina and Georgia. European colonists recognized that the region's warm climate, wetlands, and tidal waterways could support the crop. But the technical knowledge required to exploit those environments came disproportionately from West Africans. Enslaved people brought to North America from rice-growing regions of West Africa possessed knowledge of rice cultivation, irrigation, tidal agriculture, threshing, winnowing, and processing. Their expertise became a major source of the plantation economy's profitability. Planters became wealthy. Enslaved Africans paid the price. Rice cultivation in the American South was extraordinarily labor-intensive and physically punishing. Workers labored in hot, wet environments surrounded by mosquitoes and other hazards. Disease, overwork, and malnutrition contributed to exceptionally high mortality on some plantations. The familiar image of American rice as a plantation commodity therefore conceals an important historical fact. Much of the knowledge that made the industry possible was carried across the Atlantic by people who had been violently stripped of their freedom. Rice was simultaneously a source of wealth and an instrument of exploitation. Bengal famine and the colonial food system. The relationship between rice and colonial extraction was equally consequential in South Asia. Bengal was one of the world's great rice-producing regions. Under British rule, agricultural production became increasingly integrated into commercial and imperial markets. The Bengal famine of 1770 was catastrophic. Millions died amid crop failures, disease, ecological disruption, and a colonial revenue system that placed enormous pressure on rural communities. Estimates of mortality vary widely, but the death toll may have reached several million. It would be misleading to reduce the famine to a simple story of rice being exported while people starved. Famine is rarely caused by production failure alone. Prices, purchasing power, taxation, transport, entitlement, and government policy all determine whether people can obtain food. But Bengal demonstrated a fundamental danger of a commercialized food system. Producing food does not guarantee that the people who grow it will have access to it. That lesson would recur repeatedly in the modern history of agriculture. The Green Revolution. By the middle of the 20th century, the world faced a different problem. Population was increasing rapidly. Agricultural productivity in many developing countries remained low. Governments and international organizations feared that food production would fail to keep pace. Rice became one of the principal targets of scientific agriculture. In 1960, the International Rice Research Institute was established at Los Banos in the Philippines. Its objective was straightforward but extraordinarily ambitious: increase rice yields while making production more reliable. The breakthrough came in 1966 with the release of IR8. Traditional rice varieties could grow tall and produce substantial quantities of grain, but when farmers applied large amounts of nitrogen fertilizer, the plants often became too tall and fell over. This phenomenon, known as lodging, could destroy the harvest. IR8 was different. It was shorter, stronger, and capable of directing a greater proportion of its biological resources towards grain production. Given sufficient fertilizer, water, and other inputs, yields could rise dramatically. It became known as miracle rice. The implications were enormous. Countries such as India had experienced recurrent food insecurity and dependence on imports. The combination of high-yielding varieties, irrigation, fertilizer, pesticides, and improved agricultural infrastructure transformed production. Rice yields increased substantially across Asia. The Green Revolution did not solve hunger by itself, and its benefits were unevenly distributed, but it helped prevent the Malthusian catastrophe that many experts had feared. The achievement is difficult to overstate. Billions of additional people came to live in a world with access to substantially more food than previous generations had enjoyed. The hidden price of miracle rice. The Green Revolution also revealed the limitations of treating agriculture primarily as a problem of yield. High-yielding varieties were most productive when combined with irrigation, synthetic fertilizer, and pesticides. Farmers who could afford these inputs often benefited enormously. Those without access to credit, water, or infrastructure could struggle to compete. Agricultural intensification could also create environmental problems. Fertilizer runoff contributed to eutrophication. Pesticide dependence damaged ecosystems. Intensive irrigation placed pressure on rivers and aquifers. The replacement of traditional varieties with a smaller number of modern cultivars reduced genetic diversity. That last problem was particularly dangerous. When millions of hectares are planted with genetically similar crops, a disease capable of overcoming their resistance can spread rapidly. This happened with grassy stunt virus in tropical Asia during the 1970s. The vulnerability of modern rice demonstrated the importance of preserving traditional varieties. The solution came, ironically, from the genetic diversity that modern agriculture had been displacing. Researchers searched collections of traditional rice varieties for genes capable of conferring resistance. Those genes could then be incorporated into new varieties. The ancient diversity of rice became insurance for the modern food system. A world of tens of thousands of rices. There is no single rice. There are thousands upon thousands of varieties, each reflecting generations of selection by farmers and consumers. Long-grained basmati has a distinctive fragrance and elongates dramatically when cooked. Jasmine rice is prized for its aroma and soft texture. Glutinous rice, despite its name, contains very little gluten. Its stickiness comes largely from its starch composition. Arborio and other short-grained rices are valued for their ability to release starch and create the creamy texture associated with risotto. Black and purple rices contain high concentrations of anthocyanin pigments. Red rices retain colored bran layers rich in various bioactive compounds. Some varieties are adapted to drought. Others survive deep flooding. Some tolerate salt. Others thrive in cool mountain climates or poor soils. Each is a biological archive. A traditional rice variety represents not simply a genetic combination but the accumulated observations of generations of farmers who selected plants according to local conditions. When a traditional variety disappears, an irreplaceable experiment in evolutionary adaptation disappears with it. Rice in the modern world. Today, rice remains overwhelmingly an Asian crop. Asia produces roughly 90% of the world's rice, and China and India together account for more than half of global production. Indonesia, Bangladesh, Vietnam, Thailand, and Myanmar are among the other major producers. Hundreds of millions of farming households depend upon rice economically, while billions depend upon it nutritionally. Rice is unusual among major staple crops because such a large proportion of production is consumed directly by humans. It is not merely a raw material for industrial agriculture or livestock feed. It is food in its most direct sense. Rice is steamed, boiled, fermented, milled, pounded, ground into flour, transformed into noodles and turned into alcoholic beverages. It becomes sushi in Japan, nasi in Southeast Asia, biryani and pulao across South Asia, risotto in Italy, congee in China, and countless regional dishes whose identities are inseparable from the grain. Rice has therefore become both a biological species and a cultural language. The climate problem. The success of rice has created a new problem. Wetland rice cultivation can generate methane because flooded, oxygen-poor soils allow microorganisms to produce the gas as they decompose organic matter. Methane is a far more powerful greenhouse gas than carbon dioxide over a 20-year time horizon. Rice cultivation consequently contributes significantly to agricultural greenhouse gas emissions. Water is another challenge. Rice can be remarkably water-intensive, although estimates vary greatly depending upon climate, irrigation method, soil and production system. The often repeated figure of several thousand liters of water per kilogram refers to total water use or water footprint, rather than a universal amount of irrigation water physically consumed. In regions where irrigation depends heavily on groundwater, intensive rice production can contribute to declining aquifers. This is particularly serious in parts of India, China, and other major rice-growing regions where agriculture competes with cities and industry for water. Climate change compounds these pressures. Extreme heat can reduce rice fertility. High nighttime temperatures can impair grain formation and reduce yields. Drought threatens rain-fed systems, while extreme rainfall and flooding can destroy crops. Sea level rise creates another danger for the Great Asian deltas. The Mekong, Irrawaddy, and Ganges-Brahmaputra systems contain some of the world's most productive rice landscapes, but they are vulnerable to saltwater intrusion, land subsidence, storms, and changing river flows. The very environments that made rice civilization possible may become increasingly unstable. Breeding rice for a hotter world. The future of rice will depend partly on recovering the genetic diversity of its past. Scientists are developing varieties capable of tolerating drought, salinity, heat, and flooding. One of the most famous achievements has been the incorporation of the SUB1 gene into rice varieties capable of surviving prolonged submergence. Conventional rice plants can die after several days underwater. Submergence-tolerant varieties can survive around 2 weeks of complete flooding, allowing farmers to recover from flash floods that would otherwise destroy the crop. This is an extraordinary example of modern science using an ancient resource. The resistance did not appear from nowhere. It was identified in traditional rice germplasm and transferred into varieties suitable for modern agriculture. The future of rice therefore depends upon both biotechnology and biodiversity. Golden rice and the nutrition debate. Rice is an excellent source of carbohydrate but, when highly milled, provides relatively little of some micronutrients. This is particularly significant in populations where rice supplies a very large proportion of total dietary energy. Golden rice was developed to address vitamin A deficiency by engineering rice to produce beta-carotene in the edible grain. Its development generated intense scientific, political, and ethical debate. Supporters regard it as a potentially useful nutritional intervention. Opponents have raised concerns about genetic engineering, ecological effects, corporate control of agriculture, and whether technological interventions distract from broader solutions to malnutrition. Whatever position one takes on those questions, golden rice illustrates the changing role of plant breeding. Rice is no longer being bred solely to produce more grain. Scientists are attempting to make it more nutritious, more climate resilient, and less environmentally damaging. Rice comes to Europe. From Asian grain to Mediterranean crop. For most of its early history, rice was an Asian crop. Its domestication began in East Asia, and from there it spread gradually across South and Southeast Asia, eventually becoming one of the great staples of the tropical and subtropical world. Europe encountered rice much later, first as an exotic food carried along the trade routes linking the Mediterranean with the Near East and Asia. The ancient Greeks were aware of rice by the 4th century BCE. During the campaigns of Alexander the Great in India, Greek observers encountered a civilization in which rice was already an established crop. The grain subsequently became known in the Hellenistic world, and the Romans were also familiar with it. Yet rice remained an imported curiosity rather than a significant European agricultural crop. Mediterranean farmers had wheat, barley, millet, and other cereals already adapted to their climates, and there was little incentive to undertake the considerable work of cultivating a crop whose ecological requirements were unfamiliar. The decisive change came much later through the expansion of the Islamic world. Beginning in the 7th century, Arab merchants, farmers, and scholars became part of an enormous network of agricultural exchange, extending from South and Central Asia through Persia and the Middle East to North Africa and the Mediterranean. Crops and agricultural techniques traveled along these routes together. Rice moved westwards through the same interconnected world. After the Muslim conquest of most of the Iberian Peninsula beginning in 711 CE, rice cultivation became established in Al-Andalus. The achievement was not simply a matter of introducing a new seed. Rice requires reliable supplies of water and benefits enormously from careful control of irrigation and drainage. Muslim agriculturalists brought with them sophisticated hydraulic techniques that enabled previously marginal wetlands and irrigated landscapes to be turned into productive farmland. Rice became particularly important in eastern Spain, where the wetlands around Valencia provided suitable conditions. The Albufera, a vast lagoon and wetland south of the city, eventually became one of Europe's great rice-growing landscapes. Centuries later, this agricultural tradition would give Spain one of its most famous dishes, paella. The spread of rice through Islamic Spain was part of a much larger agricultural transformation. The medieval Islamic world functioned as a vast zone of crop exchange, moving plants across climatic and cultural boundaries. Sugarcane, citrus fruits, aubergines, spinach, and cotton were among the crops whose cultivation expanded through these networks. Rice was another beneficiary of this extraordinary movement of biological resources. The rise of Italian rice. Rice eventually crossed into Italy, although its precise route and chronology are less certain than the broad history of its movement through Iberia. It was known in medieval Italy before becoming an important crop, arriving through a combination of Mediterranean trade, contact with the Islamic world, and the wider movement of agricultural knowledge across southern Europe. The decisive transformation occurred in northern Italy during the late Middle Ages and Renaissance. The Po Valley was almost perfectly suited to large-scale rice cultivation. It was extraordinarily flat, crossed by rivers and streams, and capable of supporting extensive irrigation. As Italian engineers and landowners developed increasingly sophisticated systems of canals, embankments, and water control, the region acquired the infrastructure necessary for cultivating rice on a commercial scale. By the 15th and 16th centuries, rice cultivation was expanding rapidly in Lombardy and Piedmont, particularly around the provinces of Milan, Pavia, Novara, and Vercelli. Rice was an attractive crop because its productivity could be extremely high under favorable conditions. But its expansion was not universally welcomed. Authorities sometimes attempted to regulate where rice could be grown because flooded fields and stagnant water were associated with malaria and other public health concerns. The relationship between rice cultivation and malaria was complex. Mosquitoes could breed in irrigation systems, but the disease was fundamentally determined by the presence of malaria parasites, mosquito vectors, and wider environmental conditions, yet the perceived danger was sufficient to influence agricultural policy. Despite these objections, the economic advantages of rice eventually prevailed. Northern Italy became Europe's great rice-growing region. Rice becomes Italian. The transformation of rice from an imported Asian grain into a quintessentially Italian food is one of the more remarkable episodes in the crop's long history. As cultivation expanded in the Po Valley, farmers selected varieties suited to local conditions and culinary preferences. Short and medium-grain rices with high starch content proved particularly valuable because they could absorb liquid while releasing starch, creating the creamy consistency required for risotto. The great Italian rice varieties emerged from this agricultural tradition. Arborio became famous internationally, while Carnaroli and Vialone Nano became prized by chefs for their ability to retain a firm texture while producing the characteristic creaminess of a well-made risotto. By the 19th and 20th centuries, rice was no longer an exotic foreign crop in Italy. It had become embedded in the agricultural economy and culinary identity of northern Italy. The irony is striking. A grain domesticated thousands of years earlier in the wetlands of East Asia had traveled across an entire continent and eventually become the defining ingredient of one of Europe's most distinctive cuisines. Spain and the rice of Valencia. Spain followed a parallel but somewhat earlier trajectory. Rice cultivation established itself in the wetlands of Valencia under Islamic rule, and survived the political transformation that followed the Christian reconquest. Farmers continued to exploit the region's distinctive combination of warm temperatures, abundant water, and fertile wetland soils. The Albufera became the center of a specialized agricultural landscape in which rice fields were integrated with lagoons, canals, and drainage systems. Rice subsequently became fundamental to Valencian cuisine. Paella, originally associated with the agricultural communities around Valencia, evolved from a practical dish in which rice was cooked with locally available ingredients. Its later transformation into an internationally recognized symbol of Spanish cuisine illustrates how an introduced crop can become so deeply embedded in a society that its foreign origins are almost forgotten. Spain remains one of Europe's principal rice producers, with major production areas not only around Valencia but also in the Ebro Delta of Catalonia and parts of Andalusia. Portugal, Greece, and the Mediterranean. Rice cultivation also spread to Portugal, where it became established in the wetlands and river valleys of the Sado and Mondego. Portugal's Atlantic climate and extensive lowland wetlands provided suitable environments for irrigated rice. Greece developed rice cultivation particularly in northern regions, while smaller-scale production has occurred elsewhere in southeastern Europe. France provides another example of the remarkable adaptability of rice. In the Camargue, the vast Rhône River delta in southern France, rice cultivation eventually became an important component of the local agricultural economy. The modern industry was developed principally in the 20th century, particularly after the Second World War, when rice was encouraged as part of efforts to manage and exploit the region's unusual combination of freshwater, wetlands, and saline environments. European rice cultivation therefore remains concentrated in the south, where climate and water availability are most favorable. Italy is by far the continent's dominant producer, followed by Spain, with Portugal, Greece, and France contributing smaller quantities. From the Yangtze to the Po, the journey of rice into Europe illustrates a much larger pattern in human history. Crops do not remain where they are first domesticated. They travel with people. Farmers migrate and carry seeds. Merchants transport food. Conquerors move populations and agricultural practices. Religious communities exchange plants and techniques. Governments encourage crops that can generate revenue, and farmers themselves continually experiment, selecting varieties that perform best under local conditions. Rice followed all of these routes. It began as a wild grass in the wetlands of East Asia. It became an agricultural staple in China, and subsequently spread throughout Asia. It moved westward through the great networks linking India, Persia, and the Islamic world, reached North Africa and Iberia, and eventually established itself in the Mediterranean agricultural systems of Europe. Yet the journey did not end with introduction. European farmers transformed the crop once again. In Valencia, rice became the basis of paella. In northern Italy, it became risotto. In the Camargue, it became a crop adapted to the unusual ecology of the Rhône Delta. The history of European rice is therefore not a footnote to the history of an Asian crop. It is another example of the central process that has shaped human agriculture for thousands of years. The movement of plants across borders, followed by their transformation by the people who receive them. Rice entered Europe as an outsider. It stayed as a resident. And in parts of Italy and Spain, it eventually became part of the national identity. The grain that had begun its history in the wetlands of the Yangtze had traveled thousands of kilometers, crossed languages, religions, and empires, and emerged on the other side of Eurasia as one of Europe's most distinctive foods. A second rice revolution in Africa. Africa represents another frontier. The continent has a long history of rice cultivation, but demand has grown rapidly as populations increase and urban diets change. Many countries still rely heavily on imports. African rice, Oryza glaberrima, offers genetic resources adapted to African conditions. Researchers have crossed African and Asian rice to create varieties collectively known as NERICA, New Rice for Africa. The objective is to combine the hardiness of African rice with the higher yield potential of Asian rice. This is more than an agricultural experiment. It reflects a broader transformation in global food security. For much of modern history, agricultural innovation flowed predominantly from Europe and North America towards the developing world. The future may depend increasingly on combining knowledge from multiple agricultural traditions, including genetic resources preserved by smallholder farmers over thousands of years. Farming with less water and less methane. One promising approach is alternate wetting and drying. Traditional irrigated rice fields may be kept continuously flooded for much of the growing season. Alternate wetting and drying allows fields to drain periodically before being irrigated again. The technique can reduce water use and, under appropriate conditions, substantially reduce methane emissions. It also demonstrates a broader principle. The future of rice may not require abandoning intensive cultivation but redesigning it. Better water management, precision fertilization, improved varieties, integrated pest management, and more diverse farming systems could allow farmers to produce comparable quantities of rice with lower environmental costs. The challenge is not simply to produce more. It is to produce enough while using less land, water, fertilizer, and energy. The seed bank as a library of the future, perhaps the most important institution in the modern history of rice, is one that most people will never see. The International Rice Genobank at the International Rice Research Institute preserves an enormous collection of rice genetic material, numbering well over 100,000 accessions. It is effectively a library of biological possibilities. Some varieties contain genes for drought tolerance. Others contain resistance to diseases. Some tolerate flooding, salinity, or poor soils. Others possess traits that breeders may not yet understand. In a warming and increasingly unpredictable world, these genetic resources may become priceless. The logic is simple. Climate change is altering the environments in which crops grow. A variety that is unimportant today may contain the genetic solution to a problem that becomes critical tomorrow. Preserving rice diversity is therefore not an exercise in nostalgia. It is an investment in survival. The grain that built half the world. The history of rice is ultimately not the story of a plant. It is the story of a relationship between human beings, water, land, and time. From the wetlands of the Yangtze, rice accompanied the emergence of settled communities. It helped create agricultural surpluses and supported the development of states. It became the foundation of taxation and imperial logistics. It crossed mountains, rivers, and seas, transforming landscapes from Japan to Java and from India to the Philippines. It became sacred. It became money. It became an instrument of empire. It became a commodity extracted by colonial systems, and a source of wealth built upon enslaved labor. Then, in the 20th century, it became one of the central instruments of the Green Revolution, helping humanity produce enough food for a rapidly expanding population. And now rice has entered another historical phase. The problem is no longer simply how to make the plant produce more grain. The question is whether humanity can continue feeding billions of people while reducing the crop's demands on water, soil, biodiversity, and climate. That makes the future of rice unusually important. The ancient farmers of the Yangtze unknowingly began a biological experiment that has lasted nearly 10,000 years. Every generation since has modified the result, selecting seeds, moving plants, constructing terraces, breeding varieties, engineering irrigation systems, and eventually altering the plant's genome. The grain on a modern dinner plate is therefore not simply a product of nature. It is the accumulated result of thousands of years of human selection. Every grain carries traces of that history. The first wetland farmers who selected larger seeds, the engineers who built China's canals, the communities that carved rice terraces into mountains, the African farmers who domesticated their own species, the enslaved cultivators whose knowledge created American rice wealth, the breeders who produced miracle rice, and the scientists now searching ancient varieties for the traits that may allow rice to survive a hotter planet. Few foods reveal the history of civilization so completely. Rice fed armies and built states. It created wealth and inequality. It traveled farther than almost any ancient crop. It crossed cultural boundaries while becoming inseparable from local identities. Most importantly, it demonstrated one of the central facts of human history. Civilization is built not only with ideas, weapons, and institutions, but with food. The future of billions may once again depend upon a handful of seeds. Nearly 10,000 years ago, unknown farmers began transforming a wild grass into one of humanity's greatest crops. Today, humanity must transform that crop once again, not merely into more productive rice, but into rice capable of feeding the future without destroying the ecological systems upon which that future depends. The history of rice is therefore unfinished. The next chapter is being planted now.
The author has placed this work in the public domain. It may be freely imported, exported, shared, distributed, edited, modified, or reformatted without explicit consent from the author. As a visually impaired person, the author asserts his rights under the Marrakesh Treaty to facilitate access to published works for persons who are blind, visually impaired, or otherwise print disabled. 2013, wipo.int.
Share your thoughts in the comments below. Don't forget to like this video and subscribe to our channel to show your support.